Hello there, you're watching SciTech on India Science and I'm Ashwarya with you. Mirabai Chanu inaugurated India's medal tally at the Tokyo Olympics. Do you know her silver medal was sourced from discarded smartphones and laptops? She was not alone. All the medals awarded at this Olympics were recycled from electronic wastes. More on this initiative in our video.
In 2017, Japan kicked off a new initiative, and it is now bearing fruit. In the run-up to the Tokyo Olympics, Japan began collecting obsolete electronic wastes, including old smartphones, laptops, and digital cameras. The idea was to recycle them into Olympic medals. Now, you can see them hanging around the necks of people who struck gold, silver, and bronze. Between April 2017 and March 2019, the Tokyo Organizing Committee of the Olympic and Paralympic Games collected 78,985 tons of used small electronic devices, including mobile phones, contributed by people from all over Japan. After collecting them, Japan extracted these valuable metals to manufacture medals. The organizing committee reportedly removed 5,000 gold, silver, and bronze medals from these scraps. Extracting precious metals takes a series of steps. First, we will have to separate individual components of the discarded waste. The next step is to get rid of hazardous components and dispose of them safely. The following step would be to deploy either chemicals or microorganisms to leach out the precious metals. Electronic wastes are a treasure. They contain gold, silver, bronze, and other metals which can be recovered. It takes a ton of ore to get 1 gram of gold, according to the European Commission. But you can get the same amount from recycling the materials in 41 mobile phones. Typically, electronic products suffer a different fate. They end up in landfills. The world produces as much as 50 million tons of electronic and electrical waste, or e-waste. Only less than 20% of the electronic waste get recycled, according to a 2019 UN report. The initiative at Tokyo Olympics has shown us the way for a more sustainable future. Recycling electronic and electrical waste could also reduce our reliance on mining, which negatively affects the environment and wildlife. Besides, the recycling process has a lower carbon footprint than mining. According to another UN report, discarded electronics emits 80% less carbon dioxide per unit of gold than mining from the ground. The report has also recommended that producers of electrical and electronic products set up collection points where customers can drop their used products.
Virgin Galactic's Richard Branson and Blue Origin's Jeff Bezos were in the news for being a part of a suborbital flight that flew them to the edge of space and back. The edge of space is a region that is between 50 to 100 kilometers above the Earth's surface. So, what are suborbital flights and why did Branson and Bezos fly up to the edge of space? Let us find out.
On July 11, Richard Branson, founder of Virgin Group, made his maiden visit to the edge of space on the space rocket his company built. He reached an altitude of 86 kilometers. Then on July 20, Jeff Bezos, founder of Amazon, also set off to the edge of space, reaching an altitude of over 100 kilometers. He flew on his space rocket named New Shepard. Both the billionaires have set the stage for space tourism. Of course, it is for those who can afford it. It looks like the era of suborbital flight is already here. Suborbital flights are different from orbital flights. The two differ in their speeds. For an object to stay in orbit, it must attain a particular speed. Suborbital flights don't have the energy to reach the Earth's orbit. To orbit 200 kilometers above Earth, space vehicles should travel 28,000 kilometers per hour. On the other hand, a suborbital vehicle needs to fly at 6,000 kilometers per hour to reach a height of 200 kilometers above Earth. Our aeroplanes can't go to space because they don't fly at such high speeds. Though suborbital flights don't reach the Earth's orbit, passengers can still experience a few minutes of weightlessness. That's because suborbital flights fall back on Earth on a parabolic path. Imagine throwing a ball. What do you see? The ball travels in an arc through the air before reaching the ground. This is a parabolic motion. Passengers of suborbital flight experience a few minutes of weightlessness. Now, picture attaching a rocket to the ball. You will see it travel so fast that its arc shape would be the spitting image of the curvature of the Earth. When that happens, the ball would have achieved orbit and would fly at a constant height above our planet, according to space.com. Suborbital flights will do more than just entertain space enthusiasts. It could support research activities. This means scientists can study the effect of microgravity on life and run other experiments at a cheaper cost instead of performing them in the more expensive International Space Station.
And that is all for this episode of SciTech. You can send us your valuable feedback on the email ID flashing on your screen. Also, download India Science app or visit our website www.indiascience.in for more such videos. And don't forget to follow us on our social media handles as well. And before signing off, here is Fact of the Day for you. Thanks for watching. On 21st of November 1963, India launched its first suborbital rocket, Nike Apache, which was supplied by the United States.